We are in section 6.1, the polygon angle sum theorems. Let's start off with the solve it. Sketch a convex pentagon, hexagon, and heptagon. For each figure, draw all diagonals you can from one vertex. What conjecture can you make about the relationship between the number of sides of a polygon and the number of triangles formed by the diagonals from one vertex? So as you can see, we'll be working with interior and exterior angles of polygons. So here's one formula we want to be aware of. The sum of measures of the interior angles of an n-gon is the quantity of n minus 2 times 180. So let us look at problem 1. We want to know what's the sum of the interior angles of a heptagon. Well, a heptagon has 7 sides, right? So our n equals 7. Therefore, we're going to plug it into this formula up here. So it's the quantity of 7 minus 2 times 180, which means it's going to be 5 times 180, and that is going to equal 900. So our sum of our angles is 900 degrees. So let's try the got it. What is the sum of the interior angles of a 17-gon? Alright, so problem 2 asks, the common housefly, Musca domestica, has eyes that consist of approximately 4,000 facets. Each facet is a regular hexagon. What's the measure of each interior angle in one hexagonal facet? Alright, so we want to know, so here is our hexagon. We want to know the degree for one angle. This formula gives us the sum of the interior angles. So let's find the sum first. And regular hexagon means all of these angles are congruent. Alright, so if n equals 6, we're going to do 6 minus 2 quantity times 180, which is 4 times 180. It's going to give us, alright, and then we're going to divide this whole thing by 6. And that is going to give us 120 degrees. Alright, so we did the sum of the interior angles divided by 6 because there are 6 angles here. So this will give us the sum. We divide this whole thing by 6 because there are 6 angles, because 120 degrees. So got it down here. What's the measure of each interior angle in a regular nonagon? Alright. Let us look at problem 3. Alright. Problem 3 asks us, what is the measure of y in pentagon today, right here? So first what we want to do is we're given all the interior angles, right? So in order to find that, we got to add all of these add up to whatever the sum of the interior angles is. So let's find out the sum of the interior angles first of a pentagon. So it has 5 sides, so that's what our n equals. So it's going to be 5 minus 2 times 180. And that equals 540. 3 times 180, that's going to equal 540. Alright, so that's what all of these angles are going to add up to, plus that y. So we're going to subtract that off. So that's going to be 90 plus 120 plus 150 plus the measure of angle y plus 110 equals 540. So we're going to add everything together. It's going to be 470 plus measure of angle y equals 540. So measure of angle y equals 70 degrees. So we added all of them and subtracted from 540. So I got it right down here. It's kind of hard to see. What is the measure of angle G in this quadrilateral? So, see it? Alright. And then problem 4. Alright, so let's look at the exterior angle sum theorem. Alright, for a pentagon, It's saying all these angles here, when you add all of them up, it's going to equal 360. So, what is the measure 1? What is the measure of angle 1 in a regular octagon at the right? So regular means all the angles are congruent, all the sides are congruent. Alright, so by the exterior angle measure theorem, since it has 8 sides, you do 360 divided by 8, because all the exterior angles out here add up to 360. And then to find each individual one, you divide it by 8, and then you get 45. So what is the measure of an exterior angle of a regular nonagon?